Okay, question 8 moves on to means rather than proportions. All right, a random sample of 159 full-grown lobsters had a mean weight of 18 ounces. And actually, let me specify that that is the mean for our sample. So that's mu sub x bar was 18 ounces. And the standard deviation of weights of all lobsters is thought to be 2.8. 2.8. Use this data to construct a 98% confidence level. Confidence interval for the population mean of mu of weights of all such lobsters. Okay, so confidence level is 98%. So what they're wanting us to find out is what is the interval of weights that the mean of not just the sample but of all lobsters is likely to fall within. And we want the interval to be such that we'll be 98% confident that the population average falls within that interval. Our margin of error is going to equal our z-score, our critical value, times, well, we want not the population standard deviation, but the standard deviation for the distribution of sample means. So that's going to equal sigma divided by the square root of n. Now notice how here, to get the sample standard deviation, or excuse me, not the sample standard deviation, but the sampling distribution deviation, we take the population standard deviation and divide by square root of n. Now we have to evaluate the critical value. That's negative INV norm A over 2, where A equals 1 minus our confidence level. In this case, it's going to equal 0.02. And A over 2 is going to be half of that, 0.01. So this is equal to, and I get 2.326. Where am I? 2.326. Now I can evaluate this one. So I take the 2.326 and multiply by the population standard deviation 2.8, divide by the square root of 159, and I get 0.5165. 0.5165 rounded to that fourth decimal place. So that's our margin of error. So that means our confidence interval is equal to, and the confidence interval is in reference to the true mean of the total population, not just the samples mean. So that would be mu subtract E to mu plus E. Or excuse me, let's see. Let's see. That's the wrong symbol. This is just X bar. That's the sample mean. This symbol, that's if you have a distribution of sample means where your horizontal axis is X bar, and you want the mean of all that, of your sampling distribution. That's what the mu sub X bar is. And this here should be X bar. And we're saying that the population mean falls within this range with a confidence of 98%. Okay, and so we just calculate X bar minus E, so we need that number and that number. So we take 18 and subtract 0.5165. That's 17.48. And then take the 18 and add 0.5165, and that's 18.5165. I did not need a calculator for that. 17.48 and 18.51, and that is one of our answers. Another way to write this is to say 17.48 is less than the true population mean, which in turn is going to be less than 18.51, and I'll round that to 7. That's the answer to problem 8.